All right, our first example is finding the experimental probability. Oh, let me get it up on the board here. All right, so we're going to use the bar graph and the results shown. What is the experimental probability of rolling a prime number? So in order for us to find the experimental probability, we would have to have actually rolled it. But if you look at over here at this bar graph, it shows all the different times that we rolled a number cube or dice and all the different numbers that we got. Okay? So when we're looking at the experimental probability, we know we're going to find the probability, and what is our event? Well, our event is rolling a prime number. So I'm going to go ahead and put prime in the parentheses. I'm looking for the probability of getting a prime number. Okay? So I know that I'm going to make this into a ratio. The top number is going to be all the amounts that I actually got the prime number, and the denominator is going to be all the possible events total. So I'm going to start by looking at all the prime numbers. And so I have to look over here, and I look at all my different possibilities, which is 1, 2, 3, 4, 5, and 6. Not all of them are prime. I only want to look at the prime numbers. So I'm going to look at 2, I'm going to look at 3, I'm going to look at 5. Those are the prime numbers. Remember, 1 is not prime or composite. It's one of those unique numbers. And 4 is obviously even. So you have more than just 1 in itself, and same with 6. So we have 2. We rolled the 2 4 times. We rolled the 3 8 times. And we rolled the 5 11 times. And it's 11 because it's halfway between 10 and 12. So I'm going to add up those 3 numbers to find out how many times I roll the prime number. And when I add these numbers up, I get 23. So the number of times that I rolled a prime number is 23 times. I'm going to put that in my numerator. The denominator is the total number of times I've rolled the dice. So I have to take into account all 6 of the numbers. Okay? So I'm going to look at 1, and I have 10. I rolled it 10 times. A 2 I rolled 4 times. The 3 I rolled 8 times. The 4 I rolled 11 times. The 5 I rolled 11 times. And the 6 I rolled 6 times. So this is going to give me the total number of rolls that I had rolled. And when I add those 6 numbers up, I get a total of 50. So my total rolls that I rolled were 50. I'm going to go ahead and write that as my denominator. And now I have to look at my experimental probability. Can I simplify my probability? If I want to, I can. If I can leave it as 23/50ths, if I want to know the exact number, or I can leave it as a fraction. But remember, we can write probability as fractions, decimals, or percents. So I could leave my probability like this and write 23/50ths. I could write 23/50ths as a decimal, which would be 0 and 46/100ths. Or I could write it as a percent. And the percent of 46/100ths, or 23/50ths, would be 46%. So any of these answers tell me the experimental probability for this situation when I rolled my number dice.